Okay, guys, please make sure you try these problems first and then go and look at the answers. A lot of you didn't do well on last week's quiz because I felt like you didn't actually do these problems on your own, so you didn't find out what you really couldn't do, and you did not ask questions. So try these on your own first, and then come back and look at the video, and then we can talk about it. Okay, so they're telling me to graph this and to give the dilation after the scale factor. I am going to go ahead and assume this is at 0, 0, the center, because in order to perform a dilation you need a center, and this center is going to be at 0, 0 since it didn't say so. I'm going to do my scale by 2s to kind of make it easier for me, so I'm not going to write all these numbers out. I'm going to just put 2 on each one, so the person that's actually counting will know to go by 2s. Also, don't waste your time filling in all of those either. I think you can use your time for something better with actually graphing and working out the problem. So here this is -3 and 1. That's my A prime. And then over here this is -4 and -1. So 2 and then -4, -1. That's here. That's my B prime. And then C will be at -2 and -1. And that's my C prime. So my picture is a little small, but there it goes. Okay, now from my center of dilation, which is right here, I need to count to see what my vertical and horizontal component is going to be. So this is going to be 2, 3 to the left. So I'm going to say -3 times the scale factor, which is -6, and this is to help me get A prime, is 18. That is my vertical component. Not vertical, that's my horizontal component. And then I'm going to look here and see that I went up 1. So I'm going to say +1 times -6, which is -6. So to graph this, I need to move to the right 18 and down 6. So 1, 2, 3, 4, 5, 6, 7, 8, and 9. That would be 18. And then down 6. So 2, 3. That's about right here. And that's my A prime. And I'm too short. Okay, now to get the B prime, I would go here and I would count how far I am vertically over. So I'm 1, 2 to the left. So I got 2 to the left times the scale factor, which is -6. So that's going to be +12. That's my horizontal component. And then I am 1 down from that center. So I would say I would do -1 times -6, which is +6. And that's my vertical component. So I'm going to go 12 and +6. So 1, 2, 3, 4, 5, 6. And then 1, 2, 3, 4, 5, 6. My scales is in 2s, so that's 12. And then I need to go 1, 2, 3. That's 6. So this is B prime. Okay, now let's go ahead and do C. How far from the center of dilation am I with C? That is 2, and that was 2 to the left. So C prime is 2 to the left times -6, which is +12, and that's my horizontal component. And then how far down am I? I'm only 1. So I would say -1 since I'm going down times -6, which is 6, and that's my vertical component. So I go 12. So this would be 6. Oh, I need to go fix my B prime. But anyway, that would be 6 and then up by 6 and 6. So this is my C prime. So if you notice, I have a problem here. My B prime and my C prime are in the same spot. So I need to go and recount because something is wrong. Remember, dilation creates similar pictures, but one is just larger than the other one. The shape doesn't change. So I need to go back and count again. This is 2. For B prime, it is 2, 4. Oh, so I had only -2 here. I was counting by ones. So this should be -4. And then this should be +24. Okay. All right. So this is 1, 2, 3, 4, 5, 6, 7, 8, 9. So that means +24 is somewhere out here. And we're on line 6. So that is my B prime. Okay, there's some important information you need to know about similar figures, and that information is the ratio of the corresponding sides are proportional. So what you would need to say is, why do I have primes on here? What do you need to say to start with is line segment AB over line segment A prime B prime should be equal to line segment AC over AC prime should equal line segment BC over B prime C prime. And there you go. So these parts should be proportional, which when you get the proportion, you get your scale factor, which is -6. So the ratio of corresponding sides are proportional. So that just means the shape just changes side. And in this case, you notice our shape flipped. And it only flipped because the scale factor was a -6. So when your scale factor is -6 and or negative number, expect your picture to flip, but it's not going to change size or anything like that. I mean, it won't change shape. It'll change size, of course, because that's what a dilation is. And this is an enlargement. Okay, let's go to the next one. I'm going to go by 2's again. All right, so the A would be, the P would be -8 and 4. And once again, I'm just going to put -2, -2, 2, and 2 so the person will know. I'm not going to spend time actually writing all of that out. I kind of think that wastes time, especially when you only have 3 minutes per problem. Okay, so 1, 2, 3, 4, that's -8, and then 4, this is my P. And then the next one is 20 and -8. So I'm going to go 1, 2, 3, 4, 5. That's 10. This somewhere out here, babies. And then you get -8. So 1, 2, 3, 4. Wait. 1, 2, 3, 4. And that's somewhere out here. I don't have enough room, so I'm just putting it off my paper. This is 16 and 4. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2. That's R. And then we need to get S, 0 and 6. So 1, 2, 3, 4, 5, 6. And this is S. And this is some type of quadrilateral. It's almost like a trapezoid. It could be a trapezoid. Not exactly sure, but connect the dots the best way you can. And mine is a little off, but okay, we'll work with it. All right, so we're going to assume that our scale factor, our center is at 0, 0, and we know this is going to shrink and flip. So I'm going to go ahead and put my center right here, and I'm going to count. So if I go this way and do P first, then I have 1, 2, 3, 4. That's really 8 because we're going by 2's. So to get P prime, we're going to do -8 times, and I'm going to write this in fraction form. It's just easier for me to see it versus decimal form. And this is going to be +2, and this is my horizontal component. And let's see if I go and do my vertical component. That is 1, 2 to get to that point from the center. So that would be +4 times -1 over 4, which is -1. So that's my vertical component. So I'm going to go ahead and make that movement. I'm going to go to the right 2. That's 2, and then up 1. That's right here. So that is my P prime. I'm going to go to S next, and I'm lucky because all I have is a vertical component here. So I'm just going to count 2, 4, 6, 8, 10, 12. So S prime, I would get negative 12 times, I'm sorry, that's not negative, we went up, that's positive 12 times negative 1 over 4, which when you do the math, that is equal to negative 3, and that is my vertical component, and that's the only part that I need to move. So I need to go to the center and go down 3, so 2 and about 3 is right here, so that is now my S prime. And let me put that in a different color. I'm going to put it in orange, these primes. Okay, and if you notice, these letters are flipping, and that's because that's the negative sign is there. And that only happens when you have a negative. So R is 16, so I know I'm 16 over. So when I do R prime, I am 16 to the right. I'm going to times that by negative 1/4. And this is negative 4. If you count, this would have been 16. I'm a little off. Wait, 1, 2, 3, 4, 5, 6, 7. Yep, that's 8 right there. And then my vertical component is 2 and 4. This is my horizontal component. Vertical component is positive 4, and I'll multiply that by 1/4. So I get negative 1. So this is telling me to go horizontally to the left by 4, so 2, 4, and then down 1. So there we go. And that is our R prime. And the last one is to get the Q prime. We went over, I think that was 24. Q prime was 20 over. So the vertical component is 20. Then you're going to times that by negative 1 over 4. Which is equal to negative 5. That's our horizontal component. And now, how far down did I go? 1, 2, 3, 4. So that's 8. So that means I take negative 8 and multiply it by negative 1 over 4, which is 2. And that is my vertical component. And so I need to go to the left 5, so 2, 4, 5, and then we need to go up 2, so up to right here. And if you notice, the shape did flip, and we expected it to shrink and flip because the scale factor was negative. And there we go, and it did that. It shrunk down or reduced down, and then it flipped over to the other side, which is what we expected to do because scale factor was negative. Alright, if you need more practice on graphing, babies, please go back and practice more from your book, or go back and do the problems from class. Alright, so last two, it says you design a poster on an 8 by 5 inch by 11 inch paper for a contest at your school. The poster of the winner will be printed on a 34 inch by 44 inch canvas to be displayed. What is the scale factor of this dilation? So let's go in and draw a picture. It says 8 by 5 and 11, and I put the 8 by 5 at the top because it was the shorter one. That will be the width or the length, however you want to do it, doesn't matter. And then, but you do need to make sure you match the stuff up correctly. So if you put the smaller number right here, the second small number needs to go up there too. And if you put the larger number on the side, the second larger number needs to go from the side. So a few things I need to go. It says, what is the scale factor of the dilation? So if I restate this question, it's asking me, what is the K? How much did I either blow this up or reduce this? How much did I enlarge or reduce this picture? So it gave me what my first paper was, and then it tells me what the bigger paper was. So that's why I drew the two pictures. And notice, the 8.5 needs to match the 34. The 11 needs to match the 44. So your next thing is you need to determine whether K should be greater than 1, less than 1, or equal to 1. Well, we went from a small picture to a big picture, so our K needs to be greater than 1. So in this case, I need to do 34 divided into 8.5. And if they did this correctly, then both of my scale factors should be exactly the same. So I'm going to go do some math. and make sure these two K's are the same. All right, let me pull up the calculator for this one. I don't know these off the top of my head. Ooh, alrighty. So let me cancel that. Let me find the calculator and make sure that one installs correctly. Oops. Sorry guys. Oopsie. Let me get that back. Minimize it. Okay, so I need to do 34. Just a minute. 34 divided by 8.5 should be 4. And then just off the top of my head, I know 11 divided into 44 divided into 11 is 4. So there we go. So my K is equal to 4. So they took each one of these sides and blew it up by 4 inches. So my scale factor is 4 inches here. Alright, so it says a biology book shows the image of an insect that is 10 times its actual size. The image of the insect is 8 centimeters long. What is the actual length of the insect? Alright, so I need to find out how long is this insect, and it told me what the scale factor was. So it says a biology book shows the image of an insect that is 10 times its actual size. So I got some kind of bug or insect. I don't know. I'm finna draw a bug. Okay, that's my bug. And it's already blown up 10 times its size. So it's 10 here. And the image of the insect is 10 times its actual size. So that means this is actually 80. It says the image of the insect is 8 centimeters long. So my first insect was a little bit, well, maybe I should draw this a little bit smaller since it was only 8 centimeters long. Okay, so here's my little bug, and it's 8 centimeters. Okay, and it tells me the book is 10 times its actual size. So therefore, if I start with 8 centimeters, then to get the actual size of this, I just need to do the regular one times 10, because it's 8 times as big. So the K here is equal to 10 and it's greater than 1. So this is an enlargement. So what's the actual length of the insect? Oh, my bad. It said the image of the insect is 8 centimeters long, and it was blown up in the book. Okay, so I'm reading this backwards. Okay, so let's try that again, babies. Okay, the image of the insect. So I confused the image with the pre-image. So this is where they actually ended up with. So it said that it is 10 times its actual size. So this was already 10 times something. So that means that I need to find out the, let me draw this even smaller. I need to find out the size of the insect before it got blown up. Okay, so if it's already 10 times its actual size, so we have 8. And we need to figure out what did I do to get this to be 10 times its actual size. So I'm going to take 8 centimeters and divide it by 10. So that means the bug before was 8 over 10 centimeters. That's how big the one before was. Because the only way for me to get 8 centimeters back is if I multiply this fraction by 10. So 8 over 10 was the actual size of this. And if you want to reduce the fraction, it becomes 2 over 5. Wait, 4 over 5, sorry. Divide that both by 2. So it was 4/5 of a centimeter. And then when I go to blow it up 10 times its actual size, and it's 8 centimeters long, then you take this and multiply it by the by 10, and you should be able to get 8 back. All right, so go ahead, and if you need more practice problems, go ahead and practice, and I'll see you guys later. Bye.